Well, hello friends. Today we are going to implement setting IP addresses from user space. And I'm not sure how that works normally, so let's see how it works on Linux. Syscall. How to change IP address from C. Okay. So what are they doing? You make a socket, and then you have one of these things, an struct interface request or something. Okay, so you put the name of the interface in there, and then the address. This is, I guess, socket IO could set interface address, and then set interface netmask. And here we're getting flags. So, oh, and here he's setting the up flag, actually, that's what he's doing. So maybe we don't worry about this one right now, but I think, is this in any way standard? I have no idea. BSD, does BSD do this? Well, maybe they do. BSD, wait, is this? These Linux, you know? Okay, well, it seems like ifrec is the way to go. So I think we're going to do a similar thing here. And this is that struct. So I think we can just use the exact same struct as they describe here in the documentation. And where does this go? netif.h, I guess. So let's see. Well, libraries. Let's see. netif.h. Or was it the same on Linux? Well, I should just be able to do that. Yeah, there is such a thing. Okay. ifrec, it's in here. Yeah. All right. Okay. This tea is hot. Okay. So here's if.h. We'll do pragma once. Paste one of these bad boys, and where the heck do we have socket? What's a cAddr? A char address. Never heard of a cAddr before. Maybe that's some kind of yeah, let's just do a void star on that one. I don't know what's going to be in there anyway. All right. And we don't need that comment. I think we should do this. I always do this. This is just it's basically doing extern C on C++. And nothing if it's compiled as part of a C program. This is just a way that we can share the same headers between C++ and C. Anyways, so I think we're good with that struct. the main thing that we cared about. So that IO cuddle that they were doing here, this is obviously like set interface address, set interface netmask, and in both cases, we're just passing the address in if request adder here. So for our needs right now, we don't even need this part, but I'm just going to leave it in here anyway. Although we could do this. Damn it. Why can't I muscle memory this thing? Like, oh, maybe that's how we do it. You know how like when you want to do this kind of editing, we do the same thing to a bunch of lines, but it's not enough lines that you take the time to write a regex, and then you just get kind of good at doing this stupid finger pattern over and over. Anyway, so let's see what it would look like using this. So at the moment, we have ifconfig or ifconfig that looks at a proc file. So that's how I implemented it back when I did. But I'm thinking maybe we should just, at least for setting an address, we should use these. We should use IO-cuddles, because I don't yet have any instance where you send JSON to the proc file system. I mean, we could do that, but I would rather implement these IO-cuddles, I think. So anyway, let's see what we do here. So what the hell happens if you just run this right now? I'm just curious what the output looks like, because I don't quite remember. Oh yeah, right. So let's just say that if you pass the name of an interface and an IP address, then we'll set it. I guess that would be fine. So let's see if RHC is 2. Or no, 3, hold on. Then let's say string name is RHV1. Address is RHV2. And what else do we need? Actually, we can do IPv4 or auto address is. Do we have IPv4 address from string? I don't remember. Yes, we do. Nice. Okay. That's very handy. And let's see if address has value, because it returns an optional. So if it doesn't have a value, we'll say valid IPv4 address RHV2 return 1. Okay, okay, so let's see. Now let's make a socket like they were doing. So socket where's ifinet from? AFInet. What are they doing here? AFInet, PFInet. Wait, isn't the first argument supposed to be an address family? Or is there really a domain? These constants are the same anyway, so who cares? Like AFInet and BFInet, it's just the same thing, so it doesn't matter. Socket, all right. So we'll do a sock string. Doesn't matter. I think maybe actually, how does that work? Because now I'm thinking, like, how do we connect a socket to a network adapter? Because if you just instantiate a socket, oh, wait, hold on. I was thinking, like, if you just instantiate a socket, how would we know which interface you're interested in? But that's what you do here. So I guess the socket is just so that we have something to IO cuddle on. So it's sort of like, it's a little bit of a goofy API. Then it probably doesn't matter what kind of socket type we make, as long as it's an internet socket. So let's just try it this way. Okay, and then we'll do, I need a struct ifrec here. Let's do it the same way they did it. Wow, look at it. I'm programming, doing Stack Overflow programming here on Serenity. Isn't that nice? I hear that this is a very common type of program, so it's only appropriate that we do some of it here. We don't have that constant. Oh, where does that come from? Oh, we got it right here. Okay, forget I said anything. Although in this kind of case, I would much rather use size of this thing. It feels less sketchy. Although I suppose it might be a macro, so maybe ifnams is the right way to go. All right, fine. Let's stick with convention in this case. Although I do prefer doing this type of thing. Size of ifr. Oh, ifr. That's how we can say that. Ifr. All right. If what? Then we want to. Wait, what the hell is this guy doing right here? Essay data. Oh, is he trying to store the output from init baton? Well, we're gonna do it a bit less confusingly. So ifr adder, say family, it's gonna be f-init, and ifr adder dot sa data is going to be, I mean, it's a sock adder in, right, in our case. So we can do this. Or actually, I was thinking this had a sock adder in thingy. We had in adder t, sock adder in, has an in adder inside of it, which is a 32-bit, presumably network order thingy. So sin adder dot s adder should be this number. I think. Oh yeah, and there's no such thing as network order. I mean, network order doesn't matter for IP addresses because it's not a 32-bit integer. It's 4 separate octets or 8-bit integers. Yeah, anyway, so let's do one of these things. It's a struct sock adder, so we gotta do that. Okay. And dot. This adder is address dot to and header t. Oh, header some value. There we go. Okay, and now I guess we can print something here. Let's see. Setting. Let's do the interface. IPv4 address 2. Okay. It's interesting to find out how this works, how setting the IP address works, because I never knew it beyond just using ifconfig command. But it's nice to see how it's done underneath the hood and actually implementing it ourselves, of course. So why am I blanking? I just need the address. Value to string characters. All right, here we go. So, and then we can do this call IO footer. Gonna need the IO header. Saturn. Wait, did I spell that right? Fatter. Well, I guess maybe we have to add it to IO numbers. Oh, we don't have any socket IO. Fatter. Let's do sif netmask. And why not give flags and sif flags. I assume that there's like a GIF adder as well. Yeah, GIF adder, sif adder. So presumably there's like one of each. For every sif, there's a GIF. If that makes sense. Interface index name. I like that one. So we can convert between indices and names. Well, I'm not going to worry about that right now. Metrics, hardware parameters, blah, blah, blah. Set the name of the interface. Interesting. Well, I guess you can have multiple addresses. It's kind of neat. But we're not going to bother with any of that right now. We're just going to add this little list that we have here. It's a modest, but it will take us a moment to implement. So, yeah. And our argument is going to be the ifr, I guess. Okay. Whoops. It's just argument like that, right? What were they doing here? Yeah. Right. So IO returned. Okay, let's see how this works. Of course, it's not going to do anything yet because we don't implement the IO in the kernel. But it'll tell us at least if we have the IP address parsing and everything down right. And I suppose we can go and look at the socket. We don't implement IO for sockets. IO. Where do we implement that? In TTUI? Not in many places. Alright, well, we are gonna definitely override it for socket. So put it here. And then socket CPP. I'm just going to do this for now. Return e not, what's it called? E not imp? Not impl. It's just it'll just say not implemented. And oh shit. Okay, there we go. Ifconfig, and then we'll say ifconfig e1k0. All right, that's pretty good. Ifconfig, say here. Can make it look like that maybe. That's kind of neat. Okay. And I mean, presumably that error that we got was not impl. So let's switch on the request here. Gonna need those IO cuddle numbers. Notice that in sys. Yeah, okay. So, in this case, we're going to sock adder in. I guess I would actually like this to end up at the IPv4 socket, not. I'm like a layer above where I want to be, actually. So let's put this in IPv4 socket instead, so that we don't have to care about this in the base socket class. So all right. All right, and we'll take this and we'll put it in IPv4 socket. Okay. Right, yeah, this makes more sense because we don't want people to end up here. Wait, why is this thing so web content? Is that you, Mozilla? See, I trusted you for a moment and you go in and get all spinny on me. Anyways, so okay, now we're in here, which is where we want to be. Oh, we need to move this thing. Plop. All right. Let's call it adder, adder is fine. Okay, whatever. So adder is sock adder in to arg. But first we have to check that we can actually read from that place. So we'll say if current process validate read typed adder, then we gotta fail with default. Yeah, so this is how we fail with default and don't try to read from pointers that we shouldn't be reading from. Okay. And then I guess we should just get the interface. So let's see, adapter, network adapter. I want to look up my name though. Is there a lookup by name? Seems like there isn't. Well, let's just add one. From name. Lookup by name. Yeah, from my IPv4 address. Sounds a little bit like a create function to me, like a factory function. Lookup, less so. I probably named this thing, and it's not bad. It's just I like lookup a little bit better than from for this type of thing. And also, I don't think that we should use weak putters for these. I used to think it was a good idea, but I think we should switch it over to ref counting. Because my idea with the weak putter was to make hot plugging logical. So like if you unplug a network adapter physically, then the weak putter to it would become null. But the fact that the code using these has to check for null all the time, that's not good. So it would be better if they would like transition into a neutered state when they become unplugged, so that the objects would still exist. They would just not be doing anything if you try to send data through them or whatever. Anyways, that's an issue for another day. I'm not going to worry about that now. I'm just going to implement lookup by name. So it will be quite simple to implement, I suspect. Network adapter name, and we'll just do for each, let's see, network adapter. Putter, okay. For each, oopsie. Let's do this. Auto adapter. Slight name overload here. Found adapter. Okay, and then if adapter name is equal to name. Found adapter is adapter. Found adapter, if so, return a weak putter to it. Otherwise, return a. I guess we can do that. Well, it looks kind of like ass, and this reads better anyway, so let's do it that way. Okay, lookup by name. That's pretty good. This thing could be using for each as well instead of. Oh, it doesn't matter. Okay, so now we have lookup by name. And what the hell am I doing? This is not a sock getter in, this is an ifrec. H. So we need this in the kernel. I hate doing this. I'm going to put it in Unix types.h. I'll put everything in Unix types.h just to get it in the kernel. But someday, at some point, I'm going to stop duplicating things in the kernel and in libc. There needs some kind of clean solution for that. But until that day, we're just going to keep duplicating crap. So ifr is ifrec. Ifr name. Okay, hold on. We don't want to be, we have to make sure that, what's the layout of this thing? For name, and then some other stuff. So, let's be careful here and do something like ifr dot ifr name. Let's put it in our own buffer. Namesys and +1. I don't know if it can be like an interface name can be 16 bytes or what, but we're just going to be cautious here and do a mem copy name buff ifr name if namesys, and we'll say name buff if namesys, or no, size of buff. This one is a null terminator. Not falling for those tricks here. I don't know, maybe there's a more obvious way of doing that. It's just what came to mind right now. Okay. And then if adapter, or no, if not adapter, then we will return what exactly? How did we fail one of these? Man, I go net. No. What was it called again? Ciphatter error. No such device. I guess that makes sense. No such device. eno-dev. So let's do that one. No-dev. Okay, and then here, oops, adapter. Set IPv4 address. Ooh, this is spooky. Wait, what kind of argument does that take? Oh, an IPv4 address object. Well, that's pretty nice. For address constructed from what exactly? Well, just point it to the data. So ifr adder. Sock adder in dot. Wait, no, like this. Sin adder to adder. Does that work? Okay, like that. That's pretty cool. Wonder if that will actually work. And then we'll just say return 0, because I guess that's a success. Oops. Obviously, this code is not very nicely structured for adding more IO cuddles, but we'll be starting with this one and see what we do. IO cuddle numbers. You don't want me including IO cuddle numbers? Why not? Oh, because it has gunk in it. Begin deckles redefined. Maybe we can trick it into allowing inclusion of cdefs from the kernel. Say if and def begin decals. Something like that. Like that. What do you think about that, kernel? Seems like I tricked you. Socket IO code. Well, forgot to remove the virtual from the definition of socket. That's pretty cool. I mean, I know that we should be catching more errors here, I think. So like if the address is not a sockadder in, then we shouldn't be interpreting as sockadder in. So something like if, let's say family is not if inet, then we'll say EAF no support. I think that's the error that we want. Okay, oh, hold on, let me sudo sync and run. All right, buddy. So E1K0, we'll set it to 2.2 instead. IO code worked. And look at that shit. Oh man, that's so cool. It actually worked. Very interesting. And it shows up here and everything. I don't think this is live updated. We're gonna need to make it live. Oh, no, it was. Oh, look at that. Yeah, of course it's live updated. We have the packets in and out. So you can see the address changing. Oh, I love it. All right. That's so sweet. So how do we structure this so that I'm thinking like, how do we structure this so that we always get the adapter so that we can do more IO cuddles and we've already fetched the adapter? I'm not sure if all of these are going to have an ifr as the argument. Do they all take an ifr? Well, let's just assume for now that they do, and then we can worry about that later if they don't. So let's see. So auto ifr is ifrec arg, and then we'll do this. Boom. And then here we'll also do all of this cool setup we'll know beforehand. Although this one actually we have to do down here. Yeah, that's good. And then we can do GIF adder probably quite easily. So let's see how that one would look. GIF adder. In that case, we need to validate that we can also write to the pointer that we're given. So validate write typed. Otherwise, this will also be a bad access. And then we set the family to AFINet. And we say ifr adder.sa data. No, wait, hold on. Let's cast it to a sockadder in. Yeah, we'll do this whole thing here. sadder is adapter. IPv4 address to U32, I guess. And adder T. But this isn't actually an init.rt, it's just that, yeah, it's just an U32 anyway, so who cares? We can do it this way. I mean, init.rt and U32 are the same thing. I don't know why I care so much about this. That's cool. Okay, so let's test this out. In ifconfig, we can do, I guess after we do this, then we can also make an IO where we ask for the address back to us. Just give me back the address. So let's see, clear ifer, and then we copy the name again. Say ifer, or no, we don't have to say anything actually, we just call the IO. Put this here, dit. Give fatter. Oopsie. Give fatter. All right. And if this succeeds, then the ifer.iferadder should be a sock adder in containing the IPv4 address of the interface. So we'll do auto new address is IPv4 address. And sock adder in ifer adder dot synadder dot disadder. Okay, and we'll say if ifer adder family is not AFINet. Oh, we should just assert this. And we'll print final new IPv4 address, and we'll print this new address to string characters. All right. So, will it all come together? It would be nice if it did. Oh, and I think we definitely have a bug open about this. So we should make sure to close that. GitHub. Here, ifconfig, configure static IP address. It is indeed currently required to edit the code and rebuild. Which is a bit much to ask if you just want to change the IP address, I guess. So it makes sense that we would do this. Let's see, 1, 2, 3, 3, and the new address. Shit works. Now I feel like maybe we shouldn't let regular users do this. It feels like a root kind of thing, don't you think? So. Because I can query these things just fine, but what if I want to change it? What if I try to set, like, let me make an alias here. I don't know, 10.111. Yeah, right. Operation not permitted. We should definitely be giving you that if you are not root. So, if you call sifadder and if is not current process is super user, return eperm. Wait. Which one did I get? Operation not permitted. Is that the one that I want? Yeah, eperm 1. Yeah. So only super user can do it. And then we should be a bit less verbose in the ifconfig command. Of course, the ifconfig command has to grow and accept a lot more parameters, but we don't have to do them all right now. We're just we're adding this one thing, change the IP address, which is already a huge improvement to ifconfig. So e1k0 should be 3. Operation not permitted. Cool. What if I'm root though? And let me copy paste that. Plop. It totally works. Ah, very, very neat. Can we change the loopback interface to... Yes, we can. Damn, that's pretty cool. All right, so let's look at what changes we have here. So let's do cdefs by itself, because I know that get diff cached, it's just this one, so let's see. Fix warnings in cdefs if begin backwards is already defined. Yeah, because it's not the end of the world. We'll just not define it if it's already there. That doesn't matter. And then what the heck is going on with this thing? Wow, that's I mean, that's I guess that's coming from the auto formatter, but I don't like the way that looks. It makes it look like a multiplication, but it's actually a dereference. Ah, gross. I don't want to touch this in this change, so I'm just going to leave it alone, but that means that I have to go and actually touch it to make sure that it doesn't get touched. This one, where is that? Here. Oh, I can't force it to do that anyway. No. Okay, well that one I'll just ignore. Okay, so here's the new IO cuddles for IPv4 socket. What do we normally return in IO cuddle if we didn't implement it? If we fail einval. I guess we can do einval. It makes more sense. Makes more sense than not impl. Request or RGP not valid. Right. So in that case, here, einval. All right. So we get an IO cuddle on an IPv4 socket. Then we turn the argument into an ifrec pointer, and then we just verify that we're able to read from it. So validate read typed is a templated helper that uses the size of the argument. So validate read type. Let me show you how that works real quick. So yeah, so it just is templated for a type named t, and it takes a t star, and then uses the size of t to figure out how many bytes we should be able to read from this address. So it just saves you the trouble of having to pass the size of whatever you're trying to read. And I find that it seems significantly less error prone to me than if you had to actually pass the right size everywhere. Anyway, okay, so then the name buffer thing. Oh, this doesn't. We shouldn't have a temporary thing like that. We should just do this auto. Wait. Incompatible. Oh. Yeah, well, that's better. We'll store it as the right type. Okay, cool. So this code is a little bit ugly, but it's better to be on the safe side. Okay, so we look it up by its name, and then if we don't find it, we say dev. I think that's good. And then if the request is a set interface address, then we check if you're a super user. If you're not, then we eperm you. If the address you're trying to set is not an internet or an IPv4 address, then we say that address family is not supported. Let me see what's the string for that. Address family not supported by protocol. I mean, this part doesn't make sense, but I do think that that's okay. I don't know any better error for this, so you can make sense of it if you get that. And then we just interpret the if or adder as sock adder in and set the adapter's IP address to that. Cool. And return 0. Okay, and then when you try to get the interface address, we'll check if we can write to the ifer. Because if we can't write to the ifer, then we're not going to be able to store the result. Okay, and then we set the ifer's address family to IPv4, and then copy out the address as a 32-bit uint. I think that would work. I mean, we saw that it worked. Yeah. Okay, here's IO in the IPv4 socket header. Here's network adapter lookup by name. Just iterates over the adapters. That's fine. Makes a weak putter if it finds one. Yeah, like I mentioned, I want to change the way this works, but we don't have to work on that now. And here is ifrec, once in the kernel, and further away it will be once in the libc. Wait, where did that go? Oh shit, I didn't add that. netifh. Once in the kernel and once in the C library. Okay. And here are the new IO cuddles. So I added some that are not yet implemented. We'll implement them eventually. Actually, I don't want to add them if I'm not implementing them. So we'll just do this until we become good boys and come around and implement some more of these. Let's not get ahead of ourselves. Finally, the ifconfig command. Right, so actually let's fix that a little bit because now it's extremely loud. So we can put this in the debug printf, but we don't have to, or no, we don't even need to do all this printing, Jesus. I think that's actually fine. We don't need to call gifadder either. We can just call sifadder. Yep. So let's add Unix types, net, and libc sys IO numbers. Net, or no, IPv4 implement cuddles gifadder and sifadder. This allows user space programs to get and set as super user only IPv4 address of a network adapter. Cool. And ifconfig. Well, setting the IPv4 address and adapter's IPv4 address. Now do things like ifconfig u1k0 to set an adapter set the address of u1k0. Pretty neat. Is that how? I forget what the interfaces are actually called. What's that? E1K0, right? Yeah. So it's supposed to be like E1000, interface number 0. Maybe the name is silly. I don't know. I kind of like it. The Realtek ones, they look a bit weirder because it's like RTL 8139.0. So the name ends in numbers and then the index starts in numbers. So, anyway. This is pretty cool. So yeah, let's push it, I guess. And maybe we'll see it just one more time. Config. Aha. It doesn't work. Okay. It actually worked. Very, very cool. All right. So yeah, I think that's going to be it for today's video. So if you made it this far, then I thank you for watching and for hanging out. And for coming back. You know, it's nice that you're all here as often as you are. I appreciate it. And have a great day. I'll see you next time.